Hi everyone, this is the second part of CRV, Continuous Random Variable. Last week we learned about the PDF, probability density function. You can have the probability and then your X is, you have different shape of your graph of your CRV. And we learned about how to convert it into the cumulative density function. So it's always equals to 1 when it's cumulative. The probability f x always equals to 1. Well, for the probability x, it's always, okay, between 1 and 0, right? If you have a probability 1.2, something wrong with that. So in fact, a lot of things for our data is in normal distribution. Normal distribution is the data that show the tendency that closer to the center value, which is mean, and different value, different mean, and different standard deviation, you have different bell curve. And normal distribution, also called as Gaussian distribution, or some of them they call it as bell curve, right? So before we go to the normal distribution, there are two things you need to be clear. So one is population, another one is sample. So well, when I refer to the reference, some of the reference book, they define sample as when you have sample size less than 30. Well, if your size more than 30, then you are actually looking at the population. And they used to use parameters, okay, to determine the probability, and we call as statistic for sample. For the mean, we use mu for population. Standard deviation, we use sigma. And then for the sample, we use x, there is a line on top of it. And the standard deviation is using s to represent the standard deviation. So yeah, so like I mentioned to you, the normal distribution is tendency of data to get closer around a standard value, which is mean. So like in this normal distribution curve, so the usual things we look at is the mean and the standard deviation. So okay, so for example, test result, we want to look at the test result for this subject. So in order to look at so it is common to use normal distribution curve to show the performance of the test result, or we call it as bell curve. So for example, our marks is from 0 to 10. So we have some of them have performing poorly, some of them performing excellent, and majority, most of them in the middle of the majority pass and perform averagely in the class. So that is very common. Well, so like I mentioned to you, there are two things that are important for normal distribution, which is mean and standard deviation. So if you have if your graph tends to on the left side, let's say your y-axis is from 0 to 100. If your mean or your curve tend to on the left side, so it means that your mean is in the lower value compared to the your mean that most of your data on the, which means your mean on the right side. So your mean will be higher than the left skew. And if for what if we have the same mean, but we have different standard deviation? What if we have the same mean, but we have different standard deviation? So for example, as this graph A, this is B. So and we have the mean of 5, and I have the standard deviation is 0.5. So one standard deviation is 5.5. Probably not that clear. Okay, let me write it back. 5.5, and two standard deviation will be 6. This one standard deviation is 4.5, and 4 for -2 standard deviation. So if my value standard deviation is higher, for example, is 4. So my mean is still the same, is 5. So my standard deviation, one standard deviation, okay, will be 9. So for my two standard deviation, it will be 13. So for -16, okay, negative one standard deviation. So 5 minus 4 is 1, and 1 minus 4 is -3. So this is 1 standard deviation 2. This is 2 minus 2 standard deviation. It will have the 3, -3. So you can see that they are very close to each other. Well, this one is they are quite far away from each other. And in other words, if you have standard deviation is large, so your data tendency it will be a bit much spreadable compared to the standard deviation that smaller. Okay. So for normal distribution, there's one important rules that we need to learn is 68, 95, 99.7. So what are that means is actually means that within 1 plus minus 1 standard deviation, most of your data is in the range of 68%. Okay, for example, I have mean 5.5, okay, 5.5, and my standard deviation is 0.5. So plus 1 standard deviation is 6, minus 1 standard deviation is 5. So my data's 68% allocated at this area is actually about 68%. Okay, so and if I would like to now know two standard deviation, so with plus and minus 2 standard deviation, so 1, 2, 1, 2. Okay, plus, minus, minus. Okay, at this purple colors, the shaded area, the total is 95%. Whereas for plus minus 3 standard deviation, okay, it's cover 99.7% of the data in this case. You understand? So for example, I would like to know 68% the range of this data allocated at. So it's very simple. So we start with the mean, plus 1, minus 1. Okay, so it's between 5 to 6. 95, like I mentioned to you, plus 1, plus 0.5, plus another 0.5, because one standard deviation, another standard deviation. So it's 6.5. This one, the same thing. So therefore it's 4.5 to 6.5. So whereas for 3 standard deviation, it's 3 standard deviation is between 4 to 7. Okay, you can try this out. Okay, your question might be, what about 4 standard deviation, 5 standard deviation, or 6 standard deviation? So we have to know that the standard deviation is at, okay, it's never reached 0, but it's close to 0. Okay, it's when you calculate it, you still can calculate, but it will be close to 0. If you zoom this, okay, it will be close to 0, but it's not reached to 0 yet. So let's have an example, okay? My mean is 70. My standard deviation is 10. So determine the range of the data that within 68, 95, and 99.7. So first thing is I draw the mean first, okay? I start to draw the mean first. Okay. And then after that, I know that 68 is plus minus 1 standard deviation. So I know that 1 standard deviation is 10. So plus 10 minus 10, I have 60 to 80%. 60 to 80. So 95 is plus minus 2 standard deviation. So 1 and 2. Okay, so I have to plus another 10 here. What am I writing? Okay, plus another 1 here. Okay, so it becomes 90, right? Okay, so well, for this part is you have to minus another 2 times 10 because there will be 2 standard deviation. Therefore, you have the range, most of the data, 98% data, it's allocate cover within the range of 50 to 90%. Therefore, 99.7 is 3 standard deviation, so and therefore I have the answer is 40 to 80%. Okay, so normal distribution, we have various mean, we have a larger and smaller mean, we have the different of variance, standard deviation. So it's hard for us to compare, okay? So therefore, we come up with the standard normal distribution. So what is standard normal distribution is, we try to convert it into the mean into 0 and the standard deviation is always 1. So that is the standard deviation. Why we do that is because there is a table, right? When we convert into standard normal distribution, we can refer to standard normal distribution table to further find our actual mean and standard deviation. How to do that, I will show you at the next step. So before that, let me introduce you the standard normal distribution. For the first, on the top of the first row and the column, first row and first column, it's for the z-score, okay? And in the middle on that, okay, this part is actually the probability of or the shaded area of the standard normal distribution. So what that means is like this. Let's see, I can draw this out. So standard normal distribution, it's like I mentioned to you, we convert it into the mean equals to 0, standard deviation equals to 1. Okay, this is the standard normal distribution always showing the left side, the shaded area of the graph. So like I show you here. So the bottom part for the horizontal z-axis, this is the z-score. Okay, this is the z value. So I can use the z value to refer to the shaded area probability, which is, for example, I would like to know what is the probability, what is the z value for probability here. Okay, for the probability, the shaded area here is 0.5 because as you know that the whole shaded area, it should be 1, equals to 1. So if this is 0.5, this is 0.5 as well. So if we look at the 0.5, okay, not this. Okay, can you see this 0.5 is at the 0? So which is correct, like I mentioned to you, our mean always equals to 0 for the standard normal distribution curve, all right? So if you look at this table, there are two parts. One is the negative part, one is the positive part. Can you see the z-score? Okay, for example, because this one is 0, this is negative 3.9, okay? And we look at the graph of 3.9 as well. 3.9. 3.9 is 0.9995. Okay, 3.9. So what is that means is, let's say I change the color to green color. Okay, 3.9. Okay, so okay, so if you look at negative 3.9 here, okay, the shaded area here is 0.0005. Okay, for the shaded area of okay, for the shaded area of the 3.9, okay. Okay, for the shaded area of 3.9, this is the whole thing. Okay, this one is, the value is, like, as I mentioned to you, it's 99995 point. This blue color is 0.99995. If you don't have the negative way, you still can play around with the numbers. So I can show you, for example, because it's always, when you add together, it's always equals to 1. So I repeat. Okay, let me draw another one for you. Okay, so let's say I have the whole thing, right? Let's say I don't have the negative part. I only given the positive part. You still can convert it into the negative part. For example, this is, of course, this is equals to 0 gun. So let's say I have 1.2. Okay, right. But I would like to determine negative 1.2. Find the z smaller than negative 1.2. But I only have the positive one. What should I do? What should I do? So you just need to be clear with the table. So first thing is, okay, we only have positive, yeah? So I want negative 1.2. They are actually symmetry. So this part, okay, I will say this is A, B, C, and then, okay, this is D. Okay, this is D. Okay, so I can say that, okay, A equals to D. Or I can say that P Z smaller than negative 1.2 equals to BZ bigger than 1.2. Or I can say 1 minus P Z plus my 1 point. Okay, right. But the table is only show the left side. So what I can do here is now is 1 minus A plus B plus C. Agree? In order to get the D, which is, I repeat, yeah, A equals to D because they are symmetry. Okay, in order to get the D, in this table, I only have the shaded area P, Z, bigger, smaller than 1.2. Okay, so in another words means, if I want to find P, Z smaller than 1.2, it's actually equals to 1 minus Z smaller than 1.2. Why? Because A equals to D due to the symmetry, because the mean is always 0. And the Z smaller than 1.2 is this side, okay, which is you can find from here. 1.2 is 0.88493. 0.88493. 1 minus. So you just need to flip it, because when you find the D, it's actually same as the A. Okay, so you have to remember that part. It sounds a bit complicated, but it's actually not. Okay, so I hope you understand on this part. Next, go back to our slide. Okay, where are we now? Okay, so okay. So your question might be, how this happened? How we can convert this from normal distribution to standard normal distribution, and how we can use standard normal distribution to find back our actual mean and the standard deviation. It's actually very simple. It's actually referred to the Z-score equation here. So which is Z equals to X minus mean over 10. If you have your normal distribution, you want to convert to standard normal distribution, okay? Okay, so first, let's say for this example, I have my 60, my standard deviation is 10. So if I draw it as a normal distribution, this is the curve, my mean is 60, my standard deviation is 40, 80, 90. Okay, and then when I convert it, I use this equation, let's say my 60 minus 60, because my mean is 60 over 10. So I turn it become 0. So which is correct, just like the mean equals to 0. And then 40, I replace with 50. So 50 minus 60 over 10, and then I get negative 1. So like I mentioned to you, this is the standard deviation. So plus minus, this is minus standard deviation. Because this one is 0, so therefore this is negative 1. So when I use this equation, I can convert them into 0, 1, 2, 3. So, and for the standard deviation, this is plus standard deviation. Your standard deviation is 1, and therefore this is 1. This is 2. This is 3. This is negative 2. This is negative 3. Okay. The question is how we convert back from normal distribution, standard normal distribution, and then get the normal distribution. But before that, let's have a look on the how to determine some of the value from the chart first. Okay. So for the standard normal distribution, so like I mentioned to you, the table that I showed you just now is always show on your left side. On your left side. So your left side, let's say is A and B, okay? A plus B is always equals to 1, okay? If I want to get the z-score 1.2, my value z-score smaller than 1.2, it equals to A. And if you refer to the table that we looking at 1.2, you can have 88493, which is the circle one. Okay, is it okay? Let's try another one is, what is the probability of z smaller than negative 1.3? So again, we refer to the table, negative 1.85, right? So negative 1.8, 0, 1, 2, 3, 4, 1, 0, 1, 2, 3, 4, 5. So you get 0.3216 and you can get 0.3216. Try it out. And for example, okay, this one, I would like to find z-score bigger than 1.3, which is the shaded area is at the B side, okay? So what should we do? First, because the table is showing on the A, the left side. So first we find the A side, okay? As refer to the table, 1.3, okay, is 0.90320, 0.09, okay? So, and then you minus, because you want the B side, so you 1 minus the A. Your A move the other way around, therefore you can get your answer, okay? And let's try another one. I would like to find the z-score bigger than 0.65. Okay, I would like to find the z-score, the probability of z-score bigger than 0.85. So like I mentioned just now, the table only show you the left side. So therefore you use 1 minus the left side and you can get the right side area. Okay, you also can check and look for the z-score by referring to the probability of standard normal distribution table. How? Okay, for example, I would like, I have the probability of the shaded area is 0.5. What is the mean of the, what is my z-score value? So I know that without referring to the table, I can also find it is 0. Why? Because they are symmetry, remember? So we can confirm with this. Z-score equals to 0 is the shaded area is 0.5, right? So next, I have the probability is 0.8461. What is the z-score? 0.8461. So you find the nearest one, 0.8461. I think this is the closer one, 1.2. So therefore your z-score is 1.2. Okay, so you have some idea now, but how we convert it into from, how to say that, from what is the, for example, yeah, I'll give you an example. Okay, I have exam, engineering statistics exam, and the mean of the class is 60 with standard deviation of 10, okay? And what is the probability for the X is lesser than 50? What is the probability that student that score lesser than 50? So very simple. First, I convert them into the Z-score first. Okay. It's not showing the graph. Okay, so 50 minus the mean is 60 over 10, and 650 minus 60 over 10 is -1, and therefore I can refer to the table Z -1 is 0.15866. Can you see that? So I can have, you can draw it out also. Okay, this is 0.1. So the percentage of students get lesser than 50 is 0.15866, which is, I convert 50 into the standard normal distribution, which is 1. So the shaded area here and the shaded area here, it should be the same. You understand what I mean? Okay, let's try. I'm measuring the height of the student in this class, and average mean is 150 with standard deviation of 5. What is the probability of student height between 160 to 70 tall? So what should I do? So very simple. First, I draw the curve out, the bell curve out, and I have 150, and my standard deviation is 5, so 155. Okay, so I want the probability x between 160, 170. So 160, 170. Okay. So follow this. So we are looking for this part, the orange part, agree? So what I can do is, when you draw it out, it will be easier for you to look at it. I can say my x smaller than 160 minus probability x smaller than 160. Agree? And then I convert it into the z-score, 170 minus 150. 50 is the mean over the standard deviation is 5. Okay, minus, okay, the value is 160 minus 150 over 10. And therefore, my z-score is 4 minus sorry, this is 5, yeah. Agree? So 10, am I right? Yes, correct. So then you refer to the table 4. So when z smaller than 4, the closest here is 3.99. So I can have my value is 99997 minus 2. Z smaller than 2. 0.97725. Hopefully I can make it smaller. Mhm. Okay. 9 97. Okay. Nine seven seven two five. 7725. And therefore, you can have your value for this. Okay? Is that okay? And let's try. Like I mentioned, I measure my height of the student is mean 150. The standard deviation is 5. What is the probability of 160 to 170? And yeah, I just mentioned to you first, in order to find the orange color part, so I have the larger shaded area of z score equals to 107, the x equals to 170 minus the surface on the left side of x smaller than 160. So, and therefore I can have the range between the 160 to 170. So first I find the x smaller than 170. I convert it into the z score first. And next, I convert the 160 into z score as well. And after that, I minus, like I mentioned to you, and that is the answer. Okay, I hope you understand this topic, and I will see you on Monday for your test. Okay, have a lovely weekend. Bye-bye.